Morning, dear student. In today's lecture, we will discuss the next important practical of our course CHR 334 section first, that is determination of Fe titanium from this ilmenite ore. So, if you consider the formula, molecular formula for this ilmenite ore, it is Fe TiO3, and if you consider its composition, then it is titanium having 31.56% Fe, 36.81%, and oxygen 31.63%. So if you consider both titanium and this Fe, it is in +3 oxidation state. So let us discuss how will you determine. So the Fe, it is determined volumetrically. So both Fe and titanium determined volumetrically, but the method is different. So you can use different indicators and different reagent for the titrations. So let us discuss how will you determine this Fe and titanium from this ilmenite ore. So first, that is the most important thing is dissolution of ore. So to take 0.4 0.5 gram of sample of ilmenite ore, dissolve in proper amount of concentrated HCl, and evaporate the solution up to dryness. After that, you have to extract the solution. You have to extract the solution with water, then filter it and dilute the filtrate to 250 ml. So whatever the residue is there on Wattman filter paper, that is nothing but the silica which is present in your sample. So you have to dry the precipitate, and then you then ignite it and wait as SiO2. So we are very much interested in the diluted solution because we determine only Fe and titanium from this ilmenite ore. So after dilution, let us go for the further estimation of Fe. So let us discuss the procedure for estimation of Fe. Estimation of Fe. So how will you determine, or how will you find out the percentage of Fe from the diluted solution? So you have to take, let's discuss the procedure. You have to take 25 ml diluted solution, 25 ml diluted solution, then you have to add few drops, of SnCl2 and HgCl2. So what is the role of this SnCl2 and HgCl2? We discuss later on. This SnCl2 act as a reducing agent, so it undergo oxidation reaction. So it is a reducing agent. It undergo oxidation reaction and forced to another substance to undergo reduction reaction. So we know that this Fe, it is present in +3 oxidation state. So this Fe get reduced and this tin get oxidized. So you have to add few drops of SnCl2 and HgCl2. Then you have to add few ml of H2SO4 and H3PO4 acidic mixture. You have to add H2SO4 and H3PO4. So you have to make the acidic mixture, that is you have to add H2SO4 and H3PO4, and then you have to add diphenylamine as an indicator. Diphenylamine as an indicator. Diphenylamine as an indicator, and titrate the solution. With 0.1 normal potassium dichromate solution. Titrate with 0.1 normal potassium dichromate solution, and the end point of this titration is violet color changes to blue. Violet color changes to blue. Violet color changes to blue. So what is the role of this tin chloride and HgCl2 in this reaction medium or in this titration? So this is the procedure. You have to take 25 ml diluted solution, which is already diluted to 250 ml. So you have to take 25 ml diluted solution or 25 ml liquid, and then you have to add few drops of tin chloride and HgCl2. Then you have to add few ml of H2SO4 and H3PO4. Add diphenylamine as an indicator and titrate the solution with 0.1 normal potassium dichromate until a white color changes to blue. So what is the use of this tin chloride? So I already tell that this tin chloride, it is your reducing agent. So this Fe, it is present in +3 oxidation state, so it will interact with SnCl2, and the solution is already this Fe, it is already dissolved in acid. It is already dissolved in acid. If you see the dissolution process, it is already dissolved in acid, so it will forms the iron chloride complex. It will forms the chloro complex, and therefore what is the role of this tin chloride? This tin chloride, it is act as a reducing agent. It will reduce the Fe+3 into Fe+2. So it will reduce Fe+3 into Fe+2, and there is a oxidation of tin, that is from +2 oxidation state to +4 oxidation state. So what is the role of this tin chloride? The reaction is completed when yellow color of the iron third chloride complex is disappear. So this Fe is present in your solution. It is yellow color. It is yellow color complex of Fe third chloride, and it is disappear by the addition of tin chloride. The reaction is complete when the yellow color of the iron third chloride get disappear, means the Fe third is converted into Fe second, and this can be done with the help of this reducing agent, that is tin chloride, and the tin is converted into tin +4, and Fe+3 is reduced to Fe+2. So the excess tin chloride which is present in your solution is removed by the addition of HgCl2. So excess tin chloride, SnCl2, excess SnCl2, SnCl2 which is present in your solution, then it is removed with the help of this HgCl2, mercury chloride, and there is a formation of again SnCl4 plus Hg2Cl2. So you should remember, whenever you have to determine the Fe from this ilmenite ore, you have to use acidic medium, diphenylamine as indicator, and titrate with potassium dichromate. So the conversion of Fe+3 to Fe+2 is carried out with the help of this tin chloride solution, and the excess tin chloride is removed by the use of this mercury chloride solution. So this is all about the estimation of Fe from this ilmenite ore. Let us discuss the procedure for determination of titanium from the diluted solution. So determination or estimation of titanium from the diluted solution. So how will you determine this percentage? How will you find out the percentage or amount from the diluted solution? So you have to take 25 ml diluted solution, the first diluted solution, okay, the mixture of both Fe and titanium. So you have to take 25 ml diluted solution, then you have to add 0.5 gram sodium oxalate, that is Na2C2O4. You have to add 0.5 gram sodium oxalate, then you have to add ammonia till the solution is basic. Add ammonia solution till basic. Boil for 2 minutes. and then there is a formation of titanium oxalate as a precipitate. So formation of titanium oxalate as a precipitate. So you have to take diluted solution, add sodium oxalate, add ammonia till the solution is basic, boil the solution, and the formation of titanium oxalate as a precipitate. Then you have to dissolve this precipitate. Dissolve the precipitate of titanium oxalate in 1:1 HCl, 1:1 hydrochloric acid, 1:1 hydrochloric acid, and then you have to add. So let us discuss the next procedure. So this is all about. You have to take diluted solution, add sodium oxalate, and then add ammonia till the solution is basic. Boil it. So formation of titanium oxalate as a precipitate, and dissolve the precipitate in 1:1 HCl. And then you have to add 15 ml. The process is continue. The procedure is continue. Add 15 ml 0.1 normal KBRO3 potassium bromate. It is an oxidizing agent along with concentrated HCl. Along with concentrated HCl. So this is your oxidizing agent. And then you have to titrate this solution with reducing agents such as Na2H2O3. So in this case, whatever the titanium oxalate you have to dissolve in acid, so it will react with potassium bromate KBRO3, and the excess potassium bromide is then titrated with your Na2H2O3 solution. Okay, then you have to heat it. So heat the solution, then you have to add 10 ml 10% potassium iodide solution, Ki solution, and the titrate this solution, with 0.1 normal Na2H2O3 solution. Na2H2O3 solution. We already know that the endpoint of this titration, that is the dark blue color changes to green. Dark blue color changes to green. That is your endpoint of the titration. And then after that we can determine the CBR, that is constant bulletary, and then you have to find out, you have to calculate the amount of both Fe and titanium, and then you have to find out the percentage. So this is all about this ilmenite ore. You should remember its molecular formula FeTiO3, its composition, it's a dissolution process, that is you have to dissolve in acid and then evaporate up to dryness, extract with water, and dilute the filtrate to 250 ml, and then you have to take diluted solution, add tin chloride, mercury chloride solution, add acid H2SO4 H3PO4, add diphenylamine indicator, and titrate with 0.1 normal potassium dichromate for estimation of Fe. Okay, I have to take similarly the diluted solution for estimation of titanium, add sodium oxalate 0.5 grams solid sodium oxalate, then you have to add ammonia till the solution is basic, boil for a few minutes, and the formation of titanium oxalate as a precipitate, and dissolve this precipitate in acidic medium, that is dissolve in 1:1 HCl, and then you have to add 0.1 normal potassium bromate along with concentrated HCl, heat the solution and titrate with 0.1 normal Na2H2O3 solution until the dark blue color changes to green. So this is all about the determination procedure for Fe and titanium. In next lecture we will discuss the remaining practical of this course. Thank you.